We can start, I think.
During this technical, right? If someone received the group photo, please raise your hand and we'll presentation.
Because in my research, but before this, some basic information. What kind of work do I do? Yesterday, we had and then having this model, we can use the new data and check if the model is working. Okay. Usually it's working. However, the advanced element that we need to know that we using this process, we are assessing this model. Of artificial intelligence and in three types of methods. So let's see what is the difference. Processing to choose the best one. Because example. We can have historical data from the previous Excel sheets, like from the like this, but now using technologies 4.0, how we can collect the data? With sensors, right? It's now in the okay. We need to develop the predictive models. We need the data, right? But what do you think? From every data, we can develop predictive models. What do you think? In every data, what type of data? Why?
Because data is not structured. You can't do it.
Yes, of course. So I think that data collection is the most important stage in machine learning process. Why? Because the quality of the predictive models that you will develop, it depends mainly on the quality of the data. So, for instance, if the data are not accurate, if are not structured, so if you have like this outliers of the data, you know what is outlier, missing data, right? So of course we can tell generally using this data we can develop the models, but we develop the models to really predict our process. So if our data would be wrong, we will develop the models, but this model will not work. So that's why we need to take care to have very good data for developing the models. So even when we collect the data, we need to have very good some task to do. We need to choose very good data collection strategies. It means how we do something with the data from the process. Because if you want to predict the variability of the process, so the result of the process, we cannot do the data from only one day, let's say. We need to collect the data to see the changes in the process. Because we want to see the changes, we want to see the variability of the process, right? So someone will tell, okay, I need to have the data. Okay, but we will have data only from this moment. Okay, so this is very important. Data collection, we need to know what kind of data we will collect. Because you know, the type of data will also show us what kind of predictive models we have. It will be a classification problem or a regression problem, right? Because you know we have also have the continuous data from the process, right? Or data, right? We need to develop a very good data collection plan. And having this data, having this strategy. And what is also very important to collect very good quality data, the measurement system. What is measurement system?
Like an exam system?
Yes, yes. So even, okay, the measurement system, it depends. Actually, it's automatic measurement system. So it means sensor to collect the data, or even operator person who will take the data, who will, for instance, measure the light, length, or etc. So we need to be sure that even this operator is manually collecting the data, he will do it in the proper way. So he is doing all the time the same. Because if not, you will have a lot of random data like this, or this, right? So it's not good because it will not tell us about all this process, right? So this is very important to have good quality data. And how we will check this? You will check this in the second stage of the machine learning process, because as you can see here, the second stage is data pre-processing. What does it mean? Even we have not good quality data, even we have some outliers, we need to do everything to try to do from this data good quality data. Of course, without someone, but it's stupid. It's stupid because, for instance, if you have the non-reliable data, if you have some outliers, we can remove these outliers. So it means that you will take only this data who are really described as the process that we are analyzing. Okay? So for this process, you can see here, we have some strategies that we can use. So why we need to do that pre-process? As I told, because our data are incomplete, right? For instance. Okay, we will not incomplete data when we use sensors, because, but however, something can happen. One sensor can be incomplete, right? So you will not have the data. Sometimes we have some noise in the data, right? Mainly this noise is where the data are collected manually, right? So like this, I think that nobody should have salary minus 10, for instance, right? Or the age 222, right? It's 97, so it means that the birthday depends from the age, right? It's also very simple example that we have our data. During data preprocessing, we need to check all this data and find that we have such problem with the data. Because if we will put this data like model, so this model will be not good because it will not work properly, but we will do some prediction. So in data processing, we also use data cleaning, maybe in the missing data of the outliers, integration data, because sometimes mainly from the manual data collection, we have like very simple example, data is 5, 6 files, for instance, right? So we need to collect, we need to check, we need to normalize sometimes the data and do some standardization. Of course, this topic is very huge, right? But I think only today just would like to show you some problems that people have during motion, right? Sometimes we need to do something like dimensionality reduction. So what does it mean? We can develop the model having some input parameters and some output parameters, and some input parameters. But if you have our process have a lot of variables which are described as the process, it's not so, because we can develop the models, but this model will be very complicated. So it will be not useful. Something with this data. So we are on the second data processing, right? So in this stage, we can use some methods and we can use developed models. And now, what is the difference between traditional programming and machine learning programming? Do you know? Here you can see here. Maybe in traditional programming, we have some data, we have some software, and you receive some output. In machine learning, mainly in supervised learning, there is a different situation. Because maybe we have data as the inputs, we know results of the process, so we will try to find the model which explains us dependencies between our inputs and our output, how the process is working, right? So this is the difference between traditional programming and this machine learning program. And for this purpose, develop the models. We can use different methods. First group of supervised learning. Second is unsupervised learning. But what is the difference? Supervised learning methods I mainly use when we have some information about inputs of the process, variables from the process, and we know the results of the process. As you can see, we can develop the models and explain us the relation between input and output. Unsupervised learning, we are mainly using on the inputs data, and we would like to model the process. Okay, we don't know the results, but we just have the information about some variables. And supervised learning are mainly used for such problems like classification problem and regression problem. What is different between classification and regression? It mainly depends on the data of our outputs of the process. When we are studying the classification, when the output is like the class, for instance, quality of the product is okay, not okay, or for instance, our product is quality is class first, class second, class third. So these are classifications. Okay? When we are talking about the regression, so it means the output will be like the continuous data. For instance, strength, temperature, and roughness. Someone today was talking about roughness, right? Andre was talking about roughness. So this is mainly continuous data. So for this purpose, we can develop the regression model, right? Okay. As you can see here, there are problems, but we can use different models like support vector machines, decision trees, neural networks, different methods, but some of them we can use only for the classification methods. Some of them we can use only for the regression. However, like decision trees, random forests, neural networks, we can use for the board problems, classification or regression problems. So, some answer again, and so as you can see, some label data, we have outputs, we need to sometimes when you are reading or hearing about the machine learning, there are also some definitions that you need to know because some, as I was telling previously, we have inputs to the process and outputs. However, from the mathematical point of view, dependent variable and independent variable. Okay, because in many books you can find this definition. So, two of interest independent variable is like the input, but dependent variable is dependent because it depends on input to the process. Dependent variable. Data. Quality data. Use some methods to develop the models, and we are very happy. Oh yes, I have this method. I like it very much. But someone will ask, okay, have you assessed the quality of this model? What is the quality of the model? I don't know. So the quality, for the assess the quality of the models, we use some measurements, so indicators, and these measurements it depends if you have the classification model or regression model, because there are different elements. For instance, in classification model, we use some indicators which are calculated based on the confusion matrix. What is confusion matrix? It's matrix. It's not value, right? And as you can see, we have two classes of predicted values. So predicted classes and real classes. Real classes are really element that we have put it in the model, but predicted what we have received from our developed models, right? And here we have four definitions like true positive, true negative, false positive, or false negative. What does it mean? Positive, if for instance the quality of the classification model was okay, and our model also predicted that this was okay, so it's true positive. However, it could be that our input classes was not okay, and our model predicted that like positive. Like, so instance, we have our normal case, it's okay, it's false positive, and the same it is the second situation. So, okay, for us, the quality is the best when all the values from the predictions are here, right? So it means that our quality is good. Based on these values, we can calculate some indicators. As you can see, there are only these values for this confusion matrix. So based on this, we can calculate some indicators. However, the most important is accuracy. In classification models, we are talking about accuracy. So it means that this value will tell us about quality of the model, and the value of this accuracy is from 0 to 1, maybe. Always, maybe from 0 to 1. Of course, the 0 means that our model is not so good. Okay, right? So we would like to have only the models when then we are going from 0 to 1. However, of course, we want to 1. But I will tell you, 1 is not also good. Because, okay, we can be happy that we have our model 1. However, we have something like overfitting the model. So what does it mean? When we are ranking the model, so it means that model is just connected with the data that we have. So only it's fitted to our data, right? So the quality is one. So it means that sometimes it's happening like this. So it's good to have one, but from my experience, it's not to have. It's better not to have because someone can tell us, oh, it's overfitting of the model like this, right? So it's like this. But it's this indicators are from the classifications model. From the regressions model, we can use different indicators calculated like this. This is regression model is also the main indicator, and the value is the same from 0 to 1. I have developed one model. Oh, it's great. To be sure, if our models are really our process, trained very well our process, it's good to use different methods for this analysis, to develop different models, to assess these models, and to compare first the methods and the quality of them. Even using such method like decision trees, we can define different parameters for this method, right? And even based on my experience, even a little bit changing the parameters is decreasing the quality or even increasing. It depends how parameters are, but I will show you some examples about this, right? But that's why I put that the last stage, choose model, the best model, right? So it means that you need to develop different models with the different methods and then compare and choose the best one. And of course, not so happy, but to collect new data and do some slack validation. It means we need to put new raw data to our model and really see. Because usually when we are developing the model, we are dividing data in the training data and test data, right? So after test data, we can assess the quality, maybe calculating reasons accuracy, but it's very good to collect new data and put this data into this model and see what is the results. Like this. Okay? Machine learning here's not a lot of area. Even now, a lot of us has mobile phones with application of AI that artificial brains with machine learning models are working. Because why Google knows, for instance, girls were looking for a nice dress yesterday, and today they have only mainly the websites about dresses. Why? Because Google learned, right? You were looking yesterday, so now you are interested in this, right? So let's go like this. So everywhere, every day, we have examples of application machine learning in our real life, right? But of course, I'm from mechanical engineering, so I'm not using machine learning to help me to choose the best dress in the world, but only to some very good area to analyze the technical problems. But there is also, to summarize this theoretical part, would like to know that, of course, as usual, with different methods, we have advantages and disadvantages of using machine. Just of course that we have good model, we have, let's say, you can see automation, everything we can do like this. But we need to know always that if you want really have a good model, we need to have good data. I will tell you like the mantra every day. Because if you have not good data, you will not have good model. Of course, I will repeat again. I will repeat again. In every data, we can develop the models, but if the model will be good or not, depends of us. So that's why we need to have good data. We need to select good algorithms, good methods, which are appropriate for our problem that we are analyzing. Okay? So this is the critical part. Some questions? Andre, you are not that one. So let's go to the example because as I told you today, let me check the time. Just the product. So what's the problem? Because this is a part of the the weight was different. When they tried to analyze this process, even they define the tolerance plus the nominal value of the weight. So we were thinking that because the couple of years we are process. It's important and plus we have to work to help the companies who are producing the engines and the practice of this process expensive, so it's good to when you should change the pattern of the process because loss on to decrease the process. And secondly, to use this pattern as much the quality of the bread will be. We cannot use long pattern. This just directly from the machine learning. Because I'm also for the quality management from lean manufacturing, so Lean Six Sigma, I'm also working with Lean Six Sigma projects with the companies, etc., etc. So I was thinking, oh, let's do something like this. Let's firstly try to implement Six Sigma project, based on PMAKE methodology. I hope that you know what this means. It's a new approach. It's divided in some stages also with, as you can see, measuring the process, analysis, and data. So we also can define some improves that we can implement in our process. So we started with this. However, it was not good. I will show some results. So then we started to use some machine learning methods to analyze the problem. So first we tried to use random forest. I will tell you some minutes why. And then we use logistic regression and also artificial neural network. So I will tell you how different methods we use to analyze one problem and what kind of results we have received. So, as I told, process with implications of parameters, and of course this different methodologies just the different lights, like the temperature, etc. And what is important for us? It's good to know if even from the selected variables, there are some test. One thousand 1,200 examples from the different the figure of the how many times we have the same value of this process. You know, I'm sorry, I forgot the word, but you know the frequency of the frequency. Sorry, I just remind myself frequency. How many one value is in the data, and what I have received. That is huge because the frequency of each data was only twice per time like this. So it means that the variability of the data was so huge. So when I tried to put this data and develop some model, it was impossible. It was impossible. So what I did, I was the and what was other things that they have defined the tolerance for the white plus minus. Okay. However, they have the value below the tolerance. I mean the minimum value of the tolerance and the maximum value. So it means that variability was really. So it is very bad process, right? But if we need to do something, we need to do something. So who will tell me, okay, it was regression problem, but we did it like the classification problem. We just will make this. The values which are inside the tolerance define like okay value. So we have first class of the product and other results which are outside the tolerance were no okay. However, what we needed to do, we need to do the box plots to see if there are not so many outliers. You know, because if there are outliers, that's not good. A very simple example that I'm always telling my students. We have a company, we have 3 workers and 1 manager. And the salary of the workers is 1,000 zloty, let's say, or 1,000 euro. And manager is 20,000, right? And the average value is 23 divided it's 6,000. Is this company you are have a huge salary? Let's see. Can we use such in the model in something? No, because it will be wrong. So this, if we want to, we need to always remove these outliers, right? Because it will see that even average value. Many these models are built in based on average value, standard deviation. So see, the standard deviation will be like this. Average value is almost 6,000, right? So if we will try to develop the model, it will be not good, right? So, but it's normal information sometimes in the company, right? The average value of the salary is 7,000 zloty. Wow, very good company. But let's ask how it's standard salary in this company. It's 1,000 zloty, right? So this is show us that it's very important. This data preferences that I told you, right? So we cannot use all data in that. So, but let's go back to the example. So we defined that the classification and we use chi-square test because chi-square test is a very good method to show us which variables in our process are really important from a statistical point of view from our output. That's what you can see here. That from 11, only 4 are really most important, are connected really with the output of our process, right? So based on the Six Sigma project, we can do, okay, these variables are very important, so let's try to think what kind of improvement actions we can define and what we can implement in the companies, and let's do it. But for data analytics, it's not enough. Let's try to do more. We have 4 variables. And for instance, this was even temperature of the paraffin. So we started to analyze what is the range. The range also was good. So what we need to do to find the optimal value of this? We need to do some additional experiments, like using methodology design of experiments with different parameters and levels, and it will cost us a lot of money, a lot of time. So let's try to do something, right? Okay. What we did, we just started to use machine learning methods. What for? First, we started to use very simple method, Rainforest. And type of method we choose is first like based on the decision tree. Because when we use this method, we can also define the most important, we can assign because ranking of the most important variables. And what was the result? Do you remember which one was the most important variables? Yes, also the same. See? So this method as a machine learning, we don't want to operate with the detail of the predictive models, but it was not useful for us because our main goal to use this method was to confirm if from the statistical test, this method, the variables are the same, the most important. And surprise, not surprise. This just looks like this, right? So you can see that we have received the same results. It was very good information to us. Why this was so important? Because we did the next step. We used only for developing the prediction models. We don't use the all variables. We just use the most important variables because we knew that these variables are very important. So we started playing, like I always say, with machine learning. We use different methods, developed some different models. And the first model that we have developed was logistic regression. Why logistic regression? Because our output was the classificator as the classification value. And what is the main goal of logistic regression? Let's see the question, right? Because first, remember, we have used only the most important variable, right? Only 4. Right? So the equation show us also dependencies between our output and of course variables. It's not complicated. Because the data input and test data was overnight one. Right, because of the organized. So the method of using this method was is very useful as well. And what we can observe that as you can see, you can see we have very short area because we are only it should be like this, so it means that the model is not coming. Additional, we can use also artificial neural network. The specialist of the neural network is Monica. She's doing this analysis in our team. So she's a specialist of this. She also developed a model to see how we can support the prediction model, what kind of values we can put in the model to receive the results. And that's why we have used neural network model. As you can see here, I will go faster. You can see also the confusion matrix. Remember, I was telling you this about this, the values, how many so see, but the accuracy is 0.86. So you can see we have developed two methods. However, the quality is this one lower. However, it's not so very huge difference, right? It means that this model also can be used. However, still we have 40% of the error, right? In this model, right? So it's like this. So to summarize,
The previous slide, see the confusion matrix, they are like imbalance. You see, two positives are really large. And, so basically, what I'm trying to say is that if suppose if the model predicts all of them to be true positive and gives like 500 something, then plot is one and zero there for the two negatives. Then the accuracy will be good.
yes, yes.
But
So
the model
if you the whole value, it means the model is very different. If you will give this value in the so it means the quality right? So values comes from examples. So it means that so based on this data, we can see different. input parameters and output parameters. So it doesn't mean the model will learn on the data that we have. Okay, so it's like this.
Yeah.
Right? We cannot say that we have you have all of the data and 50% you need to have the output like okay, 50% you need okay, not okay. No, it's not like this.
I say everything is true positive. Everything you give, even true negatives are actually it needs to be the opposite one. 0, but it comes in 1.
Okay.
This kind of what happens is it will be good accuracy for the two positives.
Mhm.
Two negatives, if you're not concerned about two negatives,
It's not so
go straight forward.
It means that you won't have to go through all these pages to
yes,
save the time.
yes,
Now-
yes, but I was just a bit like that one to show how we can use different methods and how we can do analysis. Methods and this Like this, they start the software and they can analyze the data. If you want to write on this one, because it's awesome. And you have this machine, this has some stuff to collect the data to see how much use the but it was as you can see. We you can see here. So this was the first information. That means that if the signals of the virus changes, so it means that the computer is also to see have used to analyze this process. In the difference so we can take here like here it's a difference of Each layer, we have sharp or blunt, right? So it was also classification model. So we tried to find the difference between the parameters power. So now I would like to show you some examples how we use this in our process. So first,
So in this example of you were have some independent variables like accelerometer value
yes, actually,
and mic and all. So I
oh, yeah. Because now the data we have gigabytes of data we have collected from the field. We look at the different materials, different so part of this, that's why we use also, right? Yes. Like sharp, right? And what we have here, what we have here are the decision rules, and they'll show you directly, like here, if I will have the sharp cutter when these parameters will be like this, like this, like this. So it's like this, take this parameter about this value and this, and this, and you receive the result like this. So using decision tree, a lot of people are there, it's very simple, nothing important, but it's very good when you have want to receive the detailed information about the process. And as you can see here, there are some parameters. Remember, I was telling you that we can also change some parameters of the local methods, right? Like in decision tree, we have something like complexity parameter, how complex should be the data, how is the minus, it's how many records we have in the one element. And after 10 prediction, you need to achieve the quality. You can take values, and based on this process, we can define the confusion matrix the quality of the process, right? So, and using this, we have received very good also as you can see. This is the confusion matrix for this with accuracy almost 1. But it's not overfitted model, it was good pre-processing data, right? Because we have checked it, and the prediction value was overfitted 7%. It means very, very low. Okay? So this is with the first model. And also with this, remember I was telling you that such machine learning can also tell us which parameters are the most important. Also with the side here, right? So it means that we can analyze, we can change the, because what is the next step? Okay, machine learning is very complicated, but if we know the most important variables, we just need to simple like the analyze the frequency, what the main value, what the range of the values, etc. So after this information, we can use very simple method to look deeper, right? The problem, right? But the problem is to define this, right? So the next step, I was telling you about this, but I was not telling you about this because a lot of us I know this is such indicator out of batch. It means out of batch error. So it means if the value is the lower of the error, it means that we should take this number of trees to build the model, right? So in this case was 100 trees. And if you want to see, it's like this also. See the value of the error, it means so it doesn't have to change. However, in this case, we can see that the value, like here, if the out of which is the same constant value, so we can decrease the number of trees used in the model. This model was based on the training data and validation data because sometimes we are using only we are using all the data. But I will find something. Monica, you'll tell them. She doesn't know. Of course she knows. Why? Look, why this accuracy is one? Because this is accuracy for one training data. So based on the same data, what we developed the model, we have measured the accuracy. So it was not possible to have another bit value, right? It was one. So it's not good. However, as we are asking, when you have no zeros like this, no errors, it means that sometimes we have overfitted model, right? So it's better to check if it's like this, right? Okay. So, but for the validation data, it was also good because its accuracy was 0.98, so it means that the error was not so high, right? So it's like 9%. This logistic regression, this model, I'm presenting you to show you that look, we have the same data, but different model, the different method, and look at the confusion matrix, right? And the error is 10%. So it means that I was telling you, not all methods we can use for analyze the same problem. We can see first quality, of course we can use different methods, but we can receive the different quality of the models, right? So it was like like this, right? And some summarizing. Okay. This is the summarizing of the that was presented to you just here. What I told you. The same data with the same processing, right? But as you can see here, different accuracy and different quality. It means different quality of the, right? So that's why if you are developing models, not only one, even 2, not 3, not 4, just some of them. Okay, it's I have something like job like this that I'm not working with machine learning. I'm playing with the machine learning, right? Because you put model, you put some premise, okay, I will see. Oh, my result is like this. But put like this, my result is like this, right? And error is like this. It's good fun, not playing the stupid. Just start to work with the machine learning. Take some data one process, second process. Even you can put the data that you will find in the internet, right? Or download from the different elements and start to do it like this, right? In the on YouTube mainly because I took such learning techniques that I like not by myself only, maybe, and maybe I use the movies on YouTube. So it means that I'm watching movies and looking for the good channels because also it need to be find good channels. I'm working, I have 2 screens or 3 screens. Here is YouTube, here is my software, here's data, and I'm trying to like this, right? And even like I'm like this. So it's huge time consuming. Sometimes it's taking someone, sometimes it takes 1 day, 2 days, sometimes it takes, depends on the data, even how many data you have to take sometimes days that you will be something, right? But it's nice. So as you can see here, so some methods, some elements, some accuracy, and but it's nice. So conclusions. But some will be questions. Some questions. I hope that you will have some questions. That's it. Summarizing, it's very good to use machine learning, even for the simple problems, because as the first example I was showing you, it's very good methodology, right? To analyze from the general problem to try to go deeper, and find the right solution. Mainly to decrease the time for improvements and mainly for the company, it's good to have very simple solution, very simple area, right? To analyze the problem, right? Because they are looking for this. If they are asking the universities help us, so they will not wait very long time first, and then they want very simple solution that they can directly implement. And because sometimes it's not so easy, right? So I remember with my company, we have collected the data, but the problem was because it was in the company, they have classified the product like the class 1, class 2, class 3. And the main problem of the company that they asked us to help, it was that they have almost 60% of the final product in class 3. What is not good for the company, right? Because it means that something is wrong. So what we started to do? We started to analyze process from the beginning. And as you remember, the first step was to assess the measurement system, right? To collect the data. What we do, we have also depends from the data, type of data, different methods analyze the measurement system, like Kappa methodology, you know, what is Kappa indicator Kappa is mainly used for the attribute data method, but the continuous is LMR method. You remember? You know, something like this. So what we did, we just used Kappa first method for this. And in 1 hour, we had the main problem of this company. The operators who assess the quality, defining the class of the product, they do what they want. So when they have no standardization, first in the quality control, secondly, they should have defined the problems what can occur in the every class of the product, and what will be the range of the problem, and how they should define the class of the product, right? So they do it like they want, but because they know that they want to lose the work, the job, so for them to save was to classify the product in class 3, right? Because it was the last class, so it was like this, right? It was like so. Every step is so. As I told, good methods we can use in every area, almost for every data, but just we need to remember that to use this type of modeling, use different type of methods, and of course assess the quality, and the best solution part take another data again and move it in like this. Machine learning is very low. The other technological is digital twin. You know that we have normal technical object and digital object, and how we do the digital twin using first also, because digital twin must show us if we will put values of this, what will be the results. Well, not to be first implement the real world, right? So machine learning is of main of the part build the digital with how when show how they work, right? With the digital twin. So it's very powerful tool methods, let's say, and I encourage you next time to use it. For sure, if you want to just. Okay, so questions, please. No questions. Andre, please, I'm waiting for your question.
Thank you very much for the information. Please, suggest to people what software can be used for each purpose. Because coding, not everybody is able to.
I will start again. Method that we use to model machine it depends first mainly of the process of variables of type of the data that we have. Because as you remember, I was telling about classification regression problem, and if there is such time, we need to take the method that is useful for that problem. Secondly, I forgot to tell you something because no one asked me, but usually the question is how much data is to develop the model. How much data do I need? 10, 1,000, 10,000, 1 million? How do you think? As much as possible. However, in some cases, it's not also good enough. However, the main reason is okay. We can have as much data as we can, but the reason is how we are sampling this data from the process. As I told you, because even you have as much data we have, but only for the short element of the process, we will do nothing. I mean, not nothing. We do something, but it's not will be proper for us to analyze the flow of the process, right? So that's why, if we want to analyze the process takes 1 month. So this take like this, right? If it takes sometimes the process takes 1 year, so to collect data takes us a lot of time, right? Because as a production process, the process can be very short, and the process can be very long, yeah, right? And also the sampling of the data will depend how long is the process. If the process is very long, so we will not take data every day, but the process is very short, So even some seconds, we need to take the sample to see how the process is changing during the whole time, right? And the second, the question that I asked myself, how much data do we need? Right, you are right. Of course, we can, if we have more data, it's good. But I always telling you, remember, it's not sometimes depends how much data we have, but how is the quality of the data, right? Even if you have a smaller amount of data, sometimes it's better that we have a lot of data, but the data we can do nothing. Okay, so this is the most. But there is like using Six Sigma methodology, we have some equations that we can analyze based on tolerance the minimum value of the data. The statistical analysis, like for the control charts, I don't know if you know what's control quality management, for sure you know. So we are telling that if we have 100 data, it's enough for the short time to monitor the process, right? 100 data. However, as I thought, we have some equations that we can, based on the value of the tolerance, we can calculate the minimum value of the data that we should collect from the process, okay? Because these indicators I'm using with my students during the Six Sigma project, because there is a problem. How much data we need to collect? If I collect 50, is enough? No, you need to calculate how much data. And of course, for the continuous data, it's the smaller number of data, amount of data, the attribute data is bigger because if we even assess the quality of the, if you our parameter of quality is the length of this, it's the just the value. But if we have like the quality, okay, so even okay, to can say can make a reference was not right. That's why it's like this, right? So sometimes not number of data. So they try to take the state and etc. Because sometimes people answer
This is very important just to
According to company in March, the same was the company that we need to do it, right? That it's important, so we need to do it. So that's why I was telling them all this stuff. So I'm anything. But I don't know what to do. I'm really like that. I don't have need in my hand, so.
Thank you.
Next time we'll do some practice. Of course, we have only one half an hour, but if you have more, we could now open our laptops and I can read something. Without this, you cannot do nothing because to know how to do it, now you know what to do and how to do it. Of course, minded.
Adam to add such extra to the conference agenda. And if you like it, we can try to organize next year. So thank you very much for your contribution. Thank you very much.
Usually, it's
Us to be. This certificate was. Thank you very much. Dear participants, thank you very much for your participation. We have already prepared certificate.
I'm the member of the
Participants of workshop will receive the certificate. They are already prepared, signed by the lecturer, and will be distributed to you after the lunch. So now we have a break, and please enjoy your lunch and return to the conference hall after the lunch. And yes, you have 1 minute. Thank you very much.
Да. Просекил. Не знаю. И он меня, ну, понял. Но я потом понял, почему было это. Вот, кажется, не я это. Ушел. Нет. Ну, наверное. Наверное, ну, посмотрим. Но пока я ищу. Я теперь подписался, что там делать. Франк написал мне. Нет. У меня есть шикарный новость. Человек я добрый. И занят. Все супер. Тут договаривались, делали. Это всем сделал. Правда, народ, это неделя народ, у нас должен быть так. И он показывает, типа, шарит Teams, свой Teams для своего главное, типа, Galyna была довольна, что Нина и Георгий переходят ко мне. Как насчет самого этого? То есть без организации, без ничего. И это просто обставил между полей. Не, мой навык. Это просто решение. Ну, хорошо, организация, если что, появилась, она все. Ну, там было, знаешь, разница в писали его сообщений и тем, как он погонял, было 10 минут. То есть, по ходу лайнки, и все. И все. И вот все, какие ну, короче, я сказал, что я не сам, что у нас своих. Вот такое, если так на времени. Ну, окей, это я сейчас. Потом не хватает, он запрашивает, то есть миграции. У нас есть договоренность с ним, то есть каждый дает там что-то. Там где говорил, и он металл, я металл договорился, и сейчас учит для того, что его просто из-за перейти в сериалочки. Долго после того, это тоже, ну, не раньше. Это просто ради этого. Короче, я просто, то ты можешь потом к этому приложению понять. Ну, ладно. Если человек делает, не запись. Почему? Но я не привязывался. То есть я это правильно. Это все, знаешь, если без ничего даже. И вопрос, Yeah. Да. Лёна сказал, у меня уже все готово, мне не нужны. А Рока сказал, вот это интересно. Анна будет шагать. Он не давал добиться, чем он делал. Сейчас. Если честно, я как-то с Лидией решил, вы не попоете. Давай.